Assalamu alaikum and welcome to e-learning Al Noor International School, Grade 10 Chemistry course. I'm your chemistry teacher Fraz Anjum. Students, in this week we will study Chapter 13, State of Matter, and Lesson number 2, The Nature of Liquids. For this, we need the reference textbook page number 425 till 430. Please open your textbook page number 425. In this lesson, our main objectives are: identify the factors that determine the physical properties of a liquid, define the evaporation in terms of the kinetic energy, define the condition under which a dynamic equilibrium can exist between a liquid and its vapor, and identify the condition under which boiling occurs. So let's start. A model of liquid. What factor determine the physical properties of liquid? Before I explain this, let's see and observe two examples. Substance that can flow are referred to fluid. Means anything who can flow is called fluid. So it's not necessary only liquid can flow. Gases also. Okay, so both liquid and gases can flow. The ability of gases and liquid to flow allow them to conform to the shape of their container. You can see here, if you put any liquid into the beaker, it will take the shape of the beaker. Okay, same is, look here, gas can flow as well, and they're containing the shape of. Okay, student. Now, gases and liquids have a key differences between them. According to the kinetic theory, there are no attraction between the particle in gas. So means no intermolecular force of attraction in the between gas particles. Okay, but the particles in a liquid are attracted to each other. Means they have intermolecular force of attraction. These intermolecular force of attraction keep the particle in a liquid close together, which is why liquid have a definite volume. Okay, because of this intermolecular force of attraction, liquid have definite volume. So the interplay between the disruptive motion of the particle in a liquid and the attraction among the particles determine the physical properties of liquid. Liquids are much more dense than gases. Why? Because increasing the pressure on the liquid has hardly any effect on its volume. The same is true for solids as well. Liquid and solids are known as condensed state of matter. Okay, checkpoint please. Describe one way in which liquids and gases are similar and one way which they are different. So start. Both liquid and gas can flow. This is the similarity. So they can take shape their container. The molecule in the liquid has intermolecular force of attraction that are not present in the gas. This is the difference. Therefore, liquid have a definite volume and will not simply fill their container. Next topic is evaporation. What is the relationship between the evaporation and kinetic energy? For this, we have to discuss the vaporization. The conversion of the liquid to the gas or vapor is called vaporization. Means liquid become gas. This process is called vaporization. When this conversion occurs at the surface of the liquid that is not boiling, remember, not boiling, okay, the process is called evaporation. So it means vaporization we can divide into two. One is called evaporation, other one is called boiling. Okay, and what is vaporization? Change the state from liquid to gas is called vaporization. Okay, in this vaporization it could be evaporation or it could be boiling. So start with the evaporation. What is evaporation? The escaping the particles from the liquid surface of the liquid is called evaporation. Let's take this example, then you can understand easily. The process of evaporation has different outcomes to the open system such as lake or open container. Then is closed system such as sealed container. You can see here, as I told you, only from the surface, okay, or only from the surface. So escaping the particles or escaping the molecule from the surface, okay, of the liquid is called evaporation. Okay, so in open system, molecule that evaporate can escape from the system. Okay, see, this is the system in the bottle, and open system they can escape. But here in the closed system, the molecule collect as a vapor above the liquid. Some condense back into the liquid, means they escape from the surface, become vapor, but there is no way to go out. Then it come back, condense and back to the liquid. During the evaporation, only those molecules with a certain minimum kinetic energy can escape from the surface of the liquid. Okay, so this is important thing, that who have the kinetic energy to who can escape. So even some of the particles that do escape collide with the molecules in the air and rebound back into the liquid. Okay, a liquid evaporates faster than when heated. Okay, so heating the liquid increase the average kinetic energy of its particle. The added energy enable more particles to overcome the attractive force, keeping them in the liquid state. That's why in the summer you can dry the clothes very fast because of the sun heat. Okay, so water can going to be evaporate and the cloth become dry very fast instead of humid or rainy season or in the winter. An evaporation occurs, the particle with the highest kinetic energy tends to escape first. So the particle left in the liquid have lower average kinetic energy than the particle that have escaped. So means on the surface they have the more kinetic energy, so they can escape easily. Then so on, one by one. As evaporation take place, the liquid temperature decreases. Okay, after the evaporation, temperature become less or decrease. So evaporation is a cooling process. That's why it's called evaporation is a cooling process. Okay, let's talk about the vapor pressure now. When can dynamic equilibrium exist between a liquid and its vapor? So answer is, the evaporation of a liquid in a closed system differ from the evaporation in an open system, as we studied just now. When a partially filled container of a liquid is sealed, some of the particles at the surface of the liquid vaporize. These particles collide with the wall of the sealed container, producing the pressure, and this pressure called vapor pressure. So the measure of the force exerted by the gas above the liquid is called vapor pressure. Over the time, the number of particles entering the vapor increasing, and some of the particle condense and return to the liquid state. You can see liquid become vapor, the process called evaporation. But after some time, when the equilibrium happen, okay, the condition of dynamic equilibrium, vapor become condense and become liquid as well. Okay, so eventually the number of particles of condensing will equal to the number of particles vaporizing. Okay, on that time we can say this state called dynamic equilibrium. In a system at constant vapor pressure, the dynamic equilibrium exists between a vapor and the liquid. The system is in equilibrium because the rate of evaporation of liquid equal to the rate of condensation of vapor. Means the rate how fast evaporation going to be happen is equal to the how fast vapor going to be condensed again become liquid. On that condition we call dynamic equilibrium. So at equilibrium, the particles in the system continue to evaporate and condense, but no net change occurs in the number of particles in a liquid or vapor because it's sealed and it cannot be escaped. All right, let's take this example. To make the best tasting coffee, many people grind the coffee beans just prior to the brewing the coffee. Also, they have careful not to grind the coffee beans too much. Explain how both of these methods help the prevent and the natural oil in coffee beans from vaporizing. So natural oil can vaporize only from the surface of the coffee bean. So waiting to grind the bean keeps the surface area small as long as preventing the vaporizing. Also, not grinding the beans too much keeps the surface area lower and give less area for vaporization. Remember, in many time in the class we discussed that if there is a big size particle, it means less surface area. If you break it in the small pieces or small particle, it has the large surface area. So vapor pressure and the temperature change. An increase in the temperature of a contained liquid increase the vapor pressure. Means when you increase the temperature, vapor pressure going to be increased. This happened because the particle in a warm liquid have increased kinetic energy. More of the particle will reach the minimum kinetic energy necessary to escape the surface of the liquid. Okay, that's why when the temperature increase, the dryness of the cloth going to be faster. The vapor pressure data indicates how volatile a given liquid is and how easy to evaporate. Volatile means on the room temperature if the particle going to be escape or liquid become vapor. Okay, so you can see these are the temperatures 0, 20, 40, 60, 80, 100, and you can see the values of vapor pressure. Very less 0.6, then increase vapor pressure going to be increased when you increase more temperature, going to be more increase till you can see here at 100 degrees Celsius it become equal to the atmospheric pressure, which is 101.3 at sea level. Remember, what is it? 1 atmosphere you can say, or 101.3 kilopascal. This is the atmospheric pressure. So on the boiling point, that's why we call boiling point. Okay, we will discuss, just wait. So 100 degrees Celsius, the vapor pressure will be equal to the atmospheric pressure, which is 101.3, okay, for water. But you can see ethanol and diethyl ether is much more, okay, higher than the water, especially diethyl ether. So for three liquids shown, diethyl ether is the most volatile and water is the least volatile. Just take this is average, okay, of room temperature you can say, okay, very less pressure here, so no volatile. Ethanol there is better than water but not too much, but here you can see diethyl ether is have very high vapor pressure, so they can become the liquid to gas. Okay student, now how we can take the measurement of the vapor pressure. The vapor pressure of a liquid can be determined with the device called manometer. Manometer is a U-tube shaped column attached with the round bottom flask, okay, and with the seal cork. This cork could be rubber or anything, okay, and airtight it. Now you can see this at the standard temperature pressure, which is air, mercury, both in the both column mercury level are the same, okay, which is 1 atmosphere you can say. Okay, but if you fill with the ethanol at 0 degrees Celsius, you know there is some movement of the particle escaping from the surface. So ethanol liquid become vapors, and then this vapor trying to put the force on the mercury, so the next column mercury level going to be raised up. Take the difference from column 1 to column 2, which is this, and this is this difference called vapor pressure, which is in millimeter mercury. So how many millimeter here? You can find out by the taking the reading and minus them. After subtracting, you can get the answer. You can observe here, when you raise the temperature more, escaping more particle, exerting more pressure on the mercury, and it raised the more mercury. Okay, so the difference between two levels much higher. You can see here 43.9 millimeter mercury. So it means when you're increasing the temperature, vapor pressure going to be increased. The vapor pressure is equal to the difference in the height of the mercury in the two arms of U-tube, as I described. Please checkpoint, give this answer. I'm just going to pause this video here. All right. In sealed gas liquid system at a constant temperature, eventually what will the rate of evaporation equal to the rate of condensation? Let's talk about the boiling point. Under what conditions does boiling point occurs? So when a liquid is heated to a temperature at which particles throughout the liquid have enough kinetic energy to vaporize, the liquid begins to boil. Okay, what is it? Let's check here. Bubbles of the vapor form throughout the liquid rise the surface and escape into the air. This is called boiling, basically. So boiling point, what going to be happen? The temperature, okay, boiling point definition is the temperature at which the vapor pressure of the liquid is just equal to the external pressure on the liquid. So in easy wording, you can say boiling point is the temperature at which vapor pressure of a liquid is equal to the atmospheric pressure or external pressure of the liquid, and which is 1 atmosphere, okay, or 101.3 kilopascal. So because a liquid boils when its vapor pressure is equal to the external pressure, liquid don't always boil at the same temperature. What is mean? It's meaning, what is the boiling point of temperature water? You know this one, 100 degrees Celsius. Okay, but the water on the sea level boil on the different temperature, and on the mountain, on the hill, boil on the different temperature. We will just discuss, just wait. So because of the atmospheric pressure is lower at higher altitude, when you go up, become lower atmospheric pressure, boiling point decreases at the higher altitude. Why? As I told you, that vapor pressure of a liquid equal to the atmospheric pressure is called boiling point. So it means when you go up, atmospheric pressure going to be low. So when it's going to be low, vapor pressure become low as well, and both are equal. That's why we call boiling point going to be decreased. So take this example now. This is the water, okay? At sea level water, okay, you can see what is atmospheric pressure, 101.3 kilopascal. Okay, here at the sea level, means on the ground. So atmospheric pressure at the surface of the water at 70 degrees Celsius is greater than its vapor pressure. Bubbles of vapor cannot form in the water and it does not boil. Why? Because it's not equal. Okay, for boiling must be equal. Now check here. When you increase the heat, okay, at 100 degrees Celsius, then you can find the bubbles inside the water. Why? Because at 100 degrees Celsius, what will happen? The vapor pressure of a liquid equal to the vapor atmospheric pressure, and which is called boiling point. So that's why we call 100 degrees Celsius is the boiling point of water at sea level. Remember, at sea level means ground. But when you go top on the Mount Everest, the vapor atmospheric pressure going to be very decreased, very low. Look at this, 34 kilopascal. What is normal? 101.3, which is 1 atmosphere, but here 34 kilopascal. Very low atmospheric pressure. So because of this, at 70 degrees Celsius, water start boiling. You can see the bubble. But on the sea level, there is no bubble at 70 degrees Celsius. So at the high altitude, the atmospheric pressure is lower than it is at sea level. Thus, the water boils at a lower temperature. Okay, students, you can see the table with the normal boiling point at sea level of different substance. So, such as the normal boiling point is defined as a boiling point of a liquid at the pressure of 101.3 kilopascal. This is called normal boiling point. Okay, so these are the normal boiling point of different substance, and the most important, water, which is 100 degrees Celsius, and ethanol 78.5 degrees Celsius. That's all. 13.2. Hopefully you understood everything, and see you next week.